This presentation is part of the TI in Focus AP Calculus video series. In this video, I'll discuss the solutions, relevant concepts, and the scoring guidelines associated with some of the parts of our 2020 mock AP Calculus exam, Form AB, Question 2. My name is Steve Kokoska. I'm a recently retired professor at Bloomsburg University in Pennsylvania, and I'm a former AP Calculus chief reader. Form AB Question 2 involves a particle moving along the y-axis. Its position is modeled by a twice differentiable function y of t, where t is measured in seconds and y of t is measured in meters. We are given a table of values of y prime of t for selected values of t. And we also know the position of the particle at time t equals 12 is minus 3. In part G, we need to explain, or really justify, why there must be at least 3 times t in the interval 0 to 12, such that y prime of t is equal to 0. To solve this problem, we'll need to use this very important theorem that connects continuity and differentiability. It says that if f is differentiable at a, then f is continuous at a. So, in some sense, differentiability is a stronger property than continuity. The other key concept needed to solve this problem is the Intermediate Value Theorem. It says, suppose f is continuous on the closed interval a to b. Let capital N be any number between f of a and f of b, where f of a is not equal to f of b. Then there must be a number c in the open interval a to b such that f of c is equal to n. Let's take a closer look at this theorem. First, here's an interpretation. If the conditions are satisfied, then f takes on every value between f of a and f of b. The theorem says there is at least one value c. There certainly could be more than one. And this is an existence theorem. That means it guarantees the existence of a value c, but it doesn't tell you how to find it. I think it's important to note that the Intermediate Value Theorem is not necessarily true if the function is discontinuous anywhere in the closed interval a to b. Here are two graphs to illustrate the conclusion of the IVT, one that demonstrates what could go wrong if the function is discontinuous. In this graph, the function f is continuous on the interval a to b. Therefore, for any value n between f of a and f of b, there must be a value c between a and b such that f of c is equal to n. Now, this illustration shows f of a greater than f of b, and one such value c for the selected value of n. In this graph, the function has a point of discontinuity in the interval a to b. So the assumptions for the Intermediate Value Theorem are not met. For a selected value of n between f of a and f of b, there could be a value of c, such that f of c equals n, but we're not guaranteed that there is one. And this illustration shows there is no value of c for the selected value of n. Here's a solution to our problem. We're given that y is twice differentiable, so that means that y prime is differentiable. And therefore, by the theorem we discussed earlier, y prime is continuous on the interval 0 to 12. So the conditions for the Intermediate Value Theorem are satisfied for the function y prime on the interval 0 to 12. And we have to justify 3 values of t such that y prime of t is equal to 0. Notice from the table that y prime of t seems to oscillate back and forth between positive and negative values. Let's try to narrow this down a little. From the table, I can see that 0 is between y prime of 2 and y prime of 6. Therefore, by the intermediate value theorem, there must be at least one value, let's call it c sub 1, in the open interval 2 to 6, such that y prime of c sub 1 is equal to 0. Similarly, we can use the table to sandwich 0 between y prime of 6 and y prime of 8, and again between y prime of 8 and y prime of 10. And okay, by the intermediate value theorem, there must be at least one value in each of these intervals such that y prime is 0. So we've used the intermediate value theorem on 3 different intervals to show that there are at least 3 times in the interval 0 to 12 such that y prime is 0. Here are the scoring guidelines for part G. This problem was worth 2 points. The first point is for stating the conditions necessary to apply the intermediate value theorem. And the second point is for drawing the correct conclusion using the intermediate value theorem. Now, admittedly, there's a lot to do here for 2 points. However, I view the first point as sort of softer than the second, and a lot of the second point involves similar observations. Here are some interpretations of these scoring guidelines to help understand how points are earned and to help prepare for the next AP Calculus exam. The student must establish, convey in some manner, that the function y prime is continuous. Now, the most common response in this type of a problem is differentiable implies continuous, or differentiability implies continuity. We'll accept either of these phrases for the first point. The student must clearly indicate that differentiability implies continuity. It's just not enough to say that the function y prime is differentiable and continuous. If continuity is mentioned but not really established, and therefore the student does not earn the first point, they're still eligible for the second point. Now, some students incorrectly cite the mean value theorem instead of the intermediate value theorem, and of course, use of the MVT does not earn the second point. To earn the second point, the student must convey 3 appropriate inequalities involving 0. These inequalities can be presented in words or analytically. Here are 2 of the most common expressions for one of the intervals. And finally, the second point also requires a definitive conclusion. For example, therefore there are 3 such values. So even if the student reports that there is 1 such time in the interval 2 to 6, 1 in the interval 6 to 8, and 1 in the interval 8 to 10, they must conclude, therefore, that there are at least 3 such times in the interval 0 to 12. In part H of this problem, we need to explain why there must be at least 2 times t in the interval 0 to 12, such that y double prime of t is equal to 0. To solve this problem, we'll need to use the same theorem as in the previous part. That is, if f is differentiable at a, then f is continuous at a. The other important concept we'll need here is the mean value theorem. This says that if f is continuous on the closed interval a to b and differentiable on the open interval a to b, then there is a number c in the open interval a to b such that f prime of c is equal to the average rate of change of f over the interval a to b. This theorem is frequently tested on the AP Calculus exam, and it's used in the proofs of many advanced theorems. Because this is such an important concept, let's take a closer look at the mean value theorem. The first thing to note is that this is an existence theorem. Under certain conditions, the MVT guarantees the existence of the number c. But again, it doesn't tell you how to find it. I always feel a little let down by this, but that's the nature of an existence theorem. Rolle's theorem, which is often introduced before the mean value theorem, is just a special case of the MVT. If f of a equals f of b, that is, the value of f is the same at the endpoints of the interval, then there must be a value c in the open interval a to b where the derivative is 0. And here are two graphs to illustrate a geometric interpretation of the mean value theorem. In this graph, the slope of the tangent line to the graph of f at the point P is the same as the slope of the secant line AB. And in this graph, there are two tangent lines to the graph of f at P sub 1 and P sub 2 that are parallel to or have the same slope as the secant line AB. The mean value theorem guarantees the existence of at least one value c, but indeed there could be more than one as long as the conditions of the theorem are met. Given these background concepts, let's solve this problem. Now once again, we know that y is twice differentiable, so y prime is differentiable, and therefore y prime is continuous. Now, in order to solve this problem, we're going to have to use our result from part G. We showed that there exist 3 times, let's call them t equal a, b, and c, that satisfy this inequality and such that the value of y prime at each of these is 0. Consider these two quotients and apply the mean value theorem. There must be a value t sub 1 in the open interval a to b such that y double prime of t sub 1 is equal to y prime of b minus y prime of a over b minus a, which is 0. Similarly, by the mean value theorem applied to the function y prime, there must be a value t sub 2 in the open interval b to c such that y double prime of t sub 2 is equal to y prime of c minus y prime of b over c minus b, which is also 0. And this shows that there are at least 2 times t in the interval 0 to 12 such that y double prime of t is equal to 0. This problem was worth 2 points. The first point is for stating the conditions necessary to apply the mean value theorem, and the second point is for drawing the correct conclusion using the MVT. Now again, there's a lot going on here for 2 points, but there is some repetition here in the solution. The first point I think of as sort of soft, but a very important conceptual point, and will require some good communication for the student to earn the second point. Here are some interpretations of these scoring guidelines. Now once again, the student must establish, convey in some correct manner that the function y prime is continuous. The most common responses that we see in this type of a problem is differentiable implies continuous or differentiability implies continuity. We'll accept either of these phrases for the first point. Now, let me just remark that in a traditional AP Calculus reading, we might be willing to look back at Part G to see if the student indicated there that differentiability implies continuity. Then they wouldn't have to state this condition again. The student must clearly indicate that differentiability implies continuity. It's just not enough to say that the function y prime is differentiable and continuous. If continuity is mentioned but not established, and therefore the student does not earn the first point, they're still eligible for the second point. And finally, the second point also requires a definitive conclusion. For example, therefore there are 2 such values. And it's certainly possible for the student to earn this point without explicitly citing the mean value theorem. They can indicate the appropriate conditions and then present the correct quotients and then say, therefore, there are two such values. I hope this video gives you a good idea of how to solve these problems using the necessary AP Calculus concepts and a reasonable expectation of how they would be scored. This video concludes AB Free Response Question 2.